Hi everybody, this is Mr. Rancourt. So yesterday or previously, I taught you how to calculate the instantaneous speed. And remember I told you that the instantaneous speed was like when your parents are passing a cop who's clocking your speed and they fire the radar gun. What they're doing is they're actually want to know how fast you're going at that very second, yeah? And that's what we call instantaneous speed, the speed at a specific moment in time. So today what I want to talk about is this thing called average speed. And the average speed, and you can underline this, I'm going to highlight it, is the total distance divided by the total time taken for the entire trip. Okay? And what I mean by that, to kind of put this into perspective, is this. It's the usual, one second, the usual, and I want you to write this down, the usual speed during the entire trip. So again, the cop doesn't care that you weren't speeding when you left the driveway and that you slowed down after you passed him. The cop wants to know how fast you were traveling as you passed him. That's instantaneous speed. Well, let's suppose we just wanted to know if we were a good driver and if we usually, most of the time, follow the speed limit. Yeah, well then we're going to use this thing called average speed to calculate that. And that's the total distance traveled by the total time taken, okay? So it says to calculate the average speed for the first half of the trip, meaning on the front. So what it wants to know is from 0 to 15 seconds, yeah, what was the usual speed or what was the average speed? So in order to do that, I'm flipping back again, we need to know that first of all, the total distance traveled. Well, the total distance traveled when we started was at 0, and at 15 seconds, it was 125 meters. I'm going to zoom in so you can see that a little bit better. Let me focus it in. So the total distance we traveled from 0 to 15 seconds was 125. Because if I take 125 minus 0 on the back real quick, go ahead and write this down. 125 minus 0, you're going to get 125 meters total. Okay? And go ahead and write 125 minus 0 because Mrs. Dill wants me to make sure that I'm talking about, when we talk about slope, that we're talking about the change in speed or the change in distance or the change in time. Okay? So this shows right here how we got that. All right? Then it wants to know the total time taken. Well, we're only looking on the graph from 0 to 15 seconds. So that's 15 minus 0. Yeah? 0 to 15 seconds. Okay, so 15 minus 0. All right, and it took 15 seconds. So now, remember, speed is distance divided by time. Even if we're calculating average speed, yeah, I want the total distance traveled divided by the total time it took. So we're going to take S is equal to 125. Go ahead and write this down real quick. Divided by 15 seconds. And we're going to do meters in seconds. And then run that through a calculator. And I'm going to do that real quick because I don't know 125 divided by 15 off the top of my head. 25 divided by 15 equals. And I got this answer right here. 125 divided by 15. 8.33. Okay? And what I would suggest you do is to run that through a calculator so that you get practice on how to do it. Don't just copy down what you see on my screen because that's not going to help you at all. Okay, especially when it comes to the test, all right? So the average speed was 8.33 meters per second, all right? So what that means is from here to here, yeah, the average was about 8.3 meters per second. Now, what it wants to know is it wants to calculate the average speed for the entire trip. So not the second half, it wants the whole entire thing. So we're going to take the total distance traveled for the entire trip, which was 175, yeah? Okay, so 175 minus 0, which equals 175, minus the total time taken, which should have been 30 seconds, in a span of 30 seconds. So 30 minus 0. And again, go ahead and write this down here real quick so that you get used to seeing this, so that when you get to Mrs. Dill and she talks about slope, we're talking about change, yes? And you understand how we got change. The changes occurs when we subtract here, okay? So 30 seconds. And then same thing, you're just going to take 175 divided by 30, okay? And if I do that, you're going to get 5.83 meters per second. All right. That's it. Thanks.